This is Math 1127, Intro to Stat. This lesson is about T confidence interval and proportion confidence interval. So what is T confidence interval? So last session we talked about the Z confidence interval. You use Z, which is normal distribution, when you have large data set. So in for our class, right, it's at least 30. So just sample size is at least 30. And if you know the population's variance or standard deviation, then you can use Z, the normal distribution. If you don't know neither one of those things, right, or maybe both, right, then um, you will have to use the T distribution. T distribution was created or discovered by this guy called William Cossett. He used to work for he was an industrial engineer for for Guinness. So he used to brew beer for them basically. But when you brew those beer, you have a length of time in which you have to let it mature. And what happened is he kept coming back for him. Like the beer, they went bad. He was at the risk of losing his job, and he was using Z distribution, right, normal distribution, Z confidence interval, to estimate the time that he need to brew those beer, and he doesn't understand why it's not working. So he came up with a new distribution called T. So some people call student T distribution. Why is it called students? Because when Gossett, when he published his paper, he did not want it to be associated with his name at first because he could be wrong, right? So he just used a pen name called student, and it turned out to be one of the most important discovery in stat. T distribution is basically like normal distribution. However, it adjusts based on sample size. So when the sample size, think about it, right? If you have only 10 people you survey, say for average income or something like that, well, their the distance between them will be higher than say when you survey 100 people, right? Meaning you survey 100 people, their income, in the end, more people will be gravitate towards the middle, right? Towards maybe 30,000, 40,000, 50,000, right? But when you survey 10 people, hey, you might have a few people unemployed. You might have a few people who are millionaire business owners. So then it can vary. So that T distribution is taken into account when you have a low sample size to kind of adjust for that variance, right? So for us, the important thing is just kind of understand what it is and be able to use that for conversation. Nothing fancy, right? We're not going to go into the deep theory of those distributions. So first problem is consider the value of t such that 0.05 of the area to the right of it is t. So meaning a situation like this. So you have this a t distribution. This is t. On the right is 0.05, meaning on the right is 5% of the data. Well, then on the left would be 95%, right? Because together it's 100%, right? So you can use the formula sheet I gave you before. So you see the one tail. So the left tail, they say this like one tail, the left tail. I want one tail, but in our case, right, we want 0.05 to the right. So one tail, right, will be the right tail. One tail to 0.05, which is the middle right here, this column. So you gotta look at this column right here, basically. This column. So the question is, which number will be the answer, right? Well, the sample size is gonna kind of determine what it's gonna be. And basically, if you have say 10, let's say your sample size is 10, what's the degree of freedom? Degree of freedom will be 9 because you subtract 1. So there'll be 1.833. If your sample size is 25, say 25 right here, then degree of freedom will be 24 because you got to subtract 1, right? So that'll be 1.711. So basically the idea is that, right? And this problem is not asking you the actual number, right? But just know that it should look like this, right? So now, number 2, find the value of t with a 16 degree of freedom. So we already know In the case of this problem, right, degree of freedom equals 16. So that means the sample size is 17 for one sample. If one sample, you subtract one. Two samples, subtract two. But that's beyond the scope of this class. But to the right of the area is 0.05. Right, so 0.05 to the right. You can think about that's one tail. So what's one tail? Well, you just go to the the formula sheet again, right? So one tail, right? 0.05, which is this guy right here. And we want degree of freedom. What was the number again? 16. So 16 will be right here. That's 1.746. 1.746. That is what we call the critical value. And you can go down here. It's the same thing. 27. This is 0.01. One tail. So 0.01 will be right here. This column right here. And you want 27 degree of freedom. 27 is right here. So that'll be 2.473. 2.473. Now, I just want to let you know, none of that is too important for our purposes. This is just kind of get you to understand, how do you find those critical values. For us, it's actually, we're going to be using, for confidence interval, we'll be using calculators. This is more important for the next unit when we do hypothesis tests. But I'll talk more about by then. Find a critical t-value for a 95% confidence interval using a t-distribution with 10 degree freedom. So 95% confidence interval, same thing. You have to look at this formula right here. So this formula sheet. So look at this table, right? So let me make it a little bit bigger. There were 95% confidence interval, which is this guy. So it's a level of confidence. And 0.95 right here, this column. Now you gotta look at this first, right? So what is the degree of freedom? 10. So 10 is right here. 2.228. So 2.228 is the critical value. Right. And what that really means is when you draw the table, it's gonna be negative 2.228 on the left and positive 2.228 on the right. So, they're just gonna be, so the confidence interval would be like this. Would be like right here. Let me insert here. It will be like the right. It will be something like this. Like this. And it will be negative 2.228 and positive 2.228. And the middle will be 95%. But again, none of that doesn't really matter so much with the way we're going to solve it, because we're going to be using calculators. So as I mentioned in the last session, right? So for number 5, you are looking for the repair cost for 20. So the data set is 22 randomly selected Feasley owls. So we know right away the sample size, which is n, right, equals 22. So right from the start, we got that. Sample mean is the sample mean is 75.50, like this, and then we change that to the mean, which is this guy. So like this, right? Sample mean. And we know the standard deviation. Now, understand this is sample standard deviation, right? Not the population, because it says a sample mean and standard deviation. So that would be S equals 18.07. So not the population standard deviation, right? When it's sample, we just use S. So we want the C level to be 0.99, the confidence level, right? The confidence interval is 99%. So we need to first find the critical value. The critical value, just as we mentioned before, right? We know the degree of freedom is going to be, well, maybe I should type it like this. Degree of freedom. Remember, is one less than the sample size, right? So it's 21, right? So how do we find a critical value? Just again, look at this formula right here. So we know it's 0.99 confidence interval. So that's this column right here, 0.99. And since the degree of freedom is 21, let's look at 21. 21 is 2.831, right? So 2.831 is your critical value. Now, construct. So, oh, by the way, if you're looking for the number of sample size, like the minimum sample size and all that, that will be the number you use, right? But now, construct a 99% confidence interval. And as I mentioned, we're going to use calculator, and that's going to make it a lot easier. So how do we do it? Here, stat, test, and you go to T interval, which is number 8. Now we're going to use stat, right? That's not the data, right? We're going to use data later. So what's the sample? What's this guy? The sample mean? Let me delete all this. It look a little bit crazy. Okay, so that'll be 75.5. That's the sample mean. What's the sample standard deviation? It's 18.07. What's the n? The sample size? 22. And this confidence interval is 0.99. Now they're not going to ask you for degree of freedom. Why? Because they're going to incorporate that into their calculation. So enter. Let's see. We got it. Yeah, it takes forever, but here you go. So the lower end point is 64.592. Oh, they want 2 decimal places, so round to 2 decimal places. And then 86.41. And that's it. That's the answer. That's all you have to do. Now, I want to also show you how to do this on the website that I showed you, right? So let's go to here's the email. T confidence interval. And keep in mind, it's the same thing as a Z one. So how do we do it? So we want 2 decimal places, right? We want 99% confidence interval. We do not know the population's standard deviation. What's the sample mean? It's let's see, 75.5. Sample standard deviation is 18.07. Sample size is 22. Calculate, and let's say 64.59 to 86.41. 64.40. So from 59 and 86.41. So it's exactly the same answer. You like the website? Go use a. I mean, this is definitely easier, right? But the calculator is, you can take the calculator with you, right? It's hard to use the website when you're walking around. You can use a smartphone. You can actually use the website on your phone and get the answer. So that might be another option, right? But regardless, once you get the answer, and that's that. Let's do another one just to make sure. So a random sample of 7. So right away, I will go ahead and kind of write down all the information. Sample size is n equals 7. And then the sample mean is, and I'm gonna use the this thing again. It's gonna be x equals 1.4. All right. And then the standard deviation equals 0.23. And the C level is going to be 0.95, 95% confidence interval. And the degree of freedom equals 6, right? 1 less than 7. So now we need to find a critical value. So it's 0.95, degree of freedom is 6. So go back to that formula I gave you. 0.95, degree of freedom is 6, which is right here. So 2.447. So 2.447 is the critical value, right? Then let's use a calculator to find the confidence interval, right? So in this case, stat, test, Z interval, and again the stat, and we'll have sample mean is 1.4. standard deviation is 0.23, and the sample size is 7. Standard deviation, sea level is 95. Calculate, and we have nice 1.19, comma 1.61. And just as before, let's go ahead and put this into the website just to make sure that we got everything right. So this is 95%, right? We don't know the population, so sample means 1.4, standard deviation is 2.3. I'm sorry, 0.23, and the sample size was 7. Calculate, and I got 1.19, 1.61. 1.19, 1.61. Very nice. So again, you can use the website a lot faster. I also incorporate on my lecture. So I send you videos and my PowerPoint with information on Excel and how should you use those programs. Those are faster. It's just a little bit, it's a learning curve going into that. But some of you guys who would end up working with stat down the road, you might end up using SAS or Python. It's very similar as far as the structure of those codes. But you can always ask me if you got a question on those. Now, number 7. This guy right here is the one that with the raw data that we talk about. So now in here, you can use the website or the calculator. I'm gonna do the calculator first. So basically, you are given this data. These are the people with their test score on the exam. So I'm gonna go to stat, edit, right? And I'm gonna go ahead and clear what I have, and I'll go to on L1 on the first column. I'll go ahead and type in all the information: 23, 18, 23, 12, 13, and 23. All right. So the first thing they would like you to do here is to find the sample mean, standard deviation. So let's do that first. Remember, the way to do it is hit stat, and then one variable stat, and then I'll do second L1, right? That second one. And that gives me all the information that I needed. So the sample mean is 18.7. They will run that one decimal places. The sample standard deviation is 5.2, right? One decimal places. Find a critical value. So how do you find a critical value in this case? Think about this, right? We know the degree of freedom in this case, because the sample is 6, right? We've got 6 numbers. Degree of freedom is 5. And the C level, right, the confidence, the level of confidence is, what was it again? 80%, so 0.80. So let's go back to that formula. 0.80 is right here. And the sample, the degree of freedom is 5, right? Was it 5? Yep. So the 1.476. 1.476. That's the critical value. Again, doesn't mean much right now. It will mean a little bit more later on when we do hypothesis test. So construct an 80% confidence interval. All you need to do is put all the information here. So here's what we gotta do. Stat, test, T interval. This time we have to do data because they give us data. So data, right? L1 is the one we use, right? So if you use L2, you gotta change it. C level was 0.80, right? So 0.80, right? Calculate. It takes a little while. So that's 15.555. Or the one decimal place, so 15.6. And then 21.8. And that's the confidence interval, 80%, for the mean using T distribution. Now, let me go ahead and do this on the website, all right? So the website that we use here. Now, since you have raw data, you will have to go and click on this here. Raw data directly. We use one decimal place and it's 0.8, and we do not know the population standard deviation. So I'm just going to paste it all in there. calculate. Now you see how they give you all the sample statistics, like average, standard deviation, sample size. Skewness is basically measuring how skew, like how left and right is the population distribution going, but that doesn't matter here. So now look at this. Mean confidence interval 15.6, 21.8. 15.6, 21.8. It's the same thing. Again, it's a lot easier on the website. So that basically that's it for the T confidence interval. So, but I want to go ahead and talk about a proportion anyway, because this is another problem. It's almost the same thing, right? So maybe I can just show you real quick for this one. So this one you can copy this here, right? You might have to delete the dollar signs, right? And then 98%, and then you will get all the information. So that's actually pretty nice. Let me try that. So like this. I'm gonna delete all the dollar signs because it's probably not going to work out. You just need a comma in between. There you go. And we want a 98%. So let's calculate. And let's see. They want round to the nearest dollar. Round to the nearest dollar means, you got round to the whole number, right? So let's say 107.9, so that's 108 and 606. Hold on a sec. Oh, you know what? I forgot something. I forgot to delete the comma thing. Because the comma is going to separate the data. My bad. Let me change that. Because when you put a comma in here, they're just going to think that's another data. So now it's better. Sample size is 7. There you go. That's more like it. 46013. 46013. And the other one is 63307. There you go. So that gives you a range, a confidence interval for the mean salary of high school counselors across the United States between 46,000 to 63,307. This is a way, by the way, when you negotiate salary and stuff, this is actually a way to do it. So, but I have a better method down the road. So this is, you can use it for the calculator. I'm not going to show you, but it's the same thing as before, right? But the website goes a lot faster, right? So now, let's talk about the proportion thing. So this is the number 11, number 12 examples of proportion confidence level. So basically, the idea is, let's say I go around and survey a bunch of people for whether or not they pass this class, right? All the people who took that, all right, and see how many people pass this class. And let's say I survey maybe 100 people, and 60 of them say they pass. Then your passing rate, your success rate is 60%, right? The question is, with the 100 sample size we got, can we estimate for the entire population, is the confidence interval, is that success rate 60%? How close is that to the true success rate? We will never know, but we can get a range. We can get a confidence interval for the true success rate. So for this problem here, that deal with proportion, it's actually very simple. So we are going to use, let's say, proportion. So this is look at this problem, right? Suppose a sample of 1164 new accounts buyers is drawn. So I would say this sample size, right? N equals 1164. So we survey 1,164 people. And out of those you sample, the number of success, right, the number of success is 325. We call it X equals 325. And that's 325 people who prefer foreign cars over domestic cars. So using this data, we have to estimate the proportion of new car buyers who prefer foreign cars. The first part is actually pretty easy. The estimation, right? The estimated proportion. We call it. I used to call it this with a line right here. No, they go this. Oh, not this one. It's it's a squirrely line. Where is it at? Right here, this one. I call it this. Some people use Hatspeed. You know what? I think Hatspeed might be better. Just what is it? Hat, right? Hatspeed. Hatspeed is equal is basically X over N. That's it. That's the estimation because that's the only thing you got to go by, right? For the true proportion, the true success rate. So X over N would be 325 over 1164, right? So let's see, 325 divided by 1164, which is 0.2792. So in other words, 27.92% of people estimated would like to buy a foreign car over domestic. So I'll put 0.279 because they want you to round to 3 decimal places. So this one is easy enough. But the whole idea is to get that P, that hex P. So now, before we do the next problem, I'm just write down what I know. We know the sample size. I'm going to copy this thing. We know the sample size is that, and we also know the hex P, and I'm going to use 3 decimal places, 0.279. The number of success is X equals 325. The C level now, they want you to establish a confidence interval with 85% confidence of this particular proportion. Meaning, if I work in the next car shop or something, or car dealership, with 85% confidence, what is the success rate of people, or what is the percent of customers preferring foreign cars over domestic cars? That's basically the idea, right? So for this here, you can think about go to stat, go to test, and then you gotta scroll all the way down to one proportion, Z interval, which is A, right? And you don't even need to give them the population or the estimated proportion because they're gonna do it for you. X is 325. We got that. What's the sample size? 1164. What's the C level? 0.85. It's that easy. That's all you have to do. And then let's look at this. The answer would be, the interval would be from 0.26. They want you to round to 3 decimal places, so it would be 0. Right? And then 0.298, just like this. And that's it. The lower end and the upper end. That's it. That's that easy. You just gotta type it in and let the calculator do the work. Let's try the website anyway. This is the website because some of you guys don't have a calculator here. So decimal, we want 302. We want 3, so 3 decimal places. All right. So this is from the email, right, that I sent you, right? This way here. So now confidence interval is 0.85. Sample size is 1164. And the success, right, number of success would be 0.27. I'm sorry, 325. So let's calculate. So first they say the estimated probability of success is 0.279, which is what we have here, right? And then we are going to use Wilson score interval. There are different ways to approximate this, but we are going to use this one: 0.261, 0.299, 0.261, 0.2. I mean, it's close enough on your test, or maybe we should use normal approximation. And the reason is it really doesn't matter so much when it's like this little bit of difference on your homework. They're not gonna count as wrong, but maybe you can use this one. They use normal. So this is the answer to the, and basically that's what you do for every single one of those proportion things. So proportioning was a lot easier. You just gotta remember what command to get there, and that would conclude the lesson for both T confidence interval for mean and the confidence interval for proportion.